In this video, we're going to look at some of the exponent laws you need to know, and also how to solve some common IB maths exam questions which involve indice laws, exponent laws, and balancing equations. Okay, so I'm going to go through some of the exponent laws that we need to know. So the first one is, if we have x, let's say, squared times x cubed. So if we have the same base and we're multiplying two terms here, we need to add the powers. So this is going to be x to the power of 2 plus 3, which is x to the power of 5. And the way I remember this one is x squared is actually just x times x. And x cubed is just x times x times x. And if I'm multiplying x by x, and then x, and x, I have x to the power of 5. So that's why this is the rule. If we're multiplying terms that have the same base where we have different powers, we add the powers. Okay, second rule is if we are dividing. So let's say x to the power of 6 divided by x to the power of 3. We need to subtract the powers. Just like up here, if it was times, we added. If it's divide, we subtract. So this will be x to the power of 6 minus 3, which is x to the power of 3. And once again, how I sort of think about this is x to the power of 6 is x times x times x times x times x times x. If I'm dividing this by x to the power of 3, which is x times x times x, these will cancel out, these will cancel out, these will cancel out, and I'm left with x times x times x, which is just x cubed. So remember these two. If it's times, we add the powers. If it's divide, we subtract the powers. Okay, they're the first two rules. The third rule, if I have x to the power of 5, I'll write that again. If I have x to the power of 5 squared, so if you have a power to a power, we need to multiply the powers. So this will be x to the power of 5 times 2. So this will be x to the power of 10. Now how I think about this is x to the power of 5, well that's x times x times x times x times x. And if this is being squared, I have this multiplied by itself. So if I'm multiplying this by itself, x, 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 and they're all being multiplied, I essentially have 10 of them now, so it's x to the power of 10. So if I have a power to a power, I multiply my powers. Okay, fourth one, if you have, let's say, x, y, all to the power of 3, if you have two terms that are being multiplied and they have a power, what we can do is we can just split them up into the product of the two. So it would be x cubed times y cubed. Okay, so if this is being multiplied in here, x by y cubed, they're both to the power of 3, and we can just write it as x to the power of 3 times y to the power of 3. So that's just a basic rule there. Now this is the same as if we are dividing. So if we have x over y cubed, if you ever have a fraction to a power, we just power both of them. So it'll be x cubed over y cubed. There's a few more smaller ones. If we have x to the power of 0, if we have anything to the power of 0, this is equal to 1. So if this is an x, if this was an a, if this was any number, 5, 10, a million, anything to the power of 0 is 1. But this actually can't be 0. X can't be 0. So any non-zero number here to the power of 0 will give you 1. And a few more. If you have x to the power of, let's say, negative 3. So if you have a negative power, we can rewrite this as 1 over x cubed. So if you ever have a negative power, what that means is you can put this on the denominator and you can convert the negative power to a positive power. Okay. Now the caveat to that is if you have 1 over x to the negative 3, So if you had this, this would actually then be a negative power already on the denominator. This would actually just be x to the 3. So hopefully you can see the link there. And the last one I want to go through is if you have a fractional power. So if you have x to the power of, let's say, 5 on 3, the top number of the fraction, the numerator, stays on top of the x. So it will be x to the power of 5. And what the bottom number is this is the root. So if this is a 3, it's the cubed root of x to the power of 5. So if you have a fractional power, the bottom number is the root, and the top number is what's going to stay on top of the x. Now, if this is a 2 on the bottom here, it's the square root, and we actually don't need to write a little 2 here. The square root, if we don't have a number, we assume it's a 2. Okay, so these are all of our indice laws. You may have seen these before in your textbook using different letters, A's and B's, and you might have X's and Y's, but we need to make sure that we know that if we have the same bases and we're multiplying, we add the powers, dividing, we subtract the powers, a power to a power, we multiply the powers, and then if it's multiplied, you power both, divide, you power both. Anything to the power of 0 is 1. A negative power just means you put it on the denominator and make it a positive power, and then a fractional power can be written like this. Okay, so I'm going to do one example question. Let me get my example. Okay, so in IB questions, they often ask you to solve for some unknown value. Let's just say it's x, and they'll give you an equation. So an example would be 1 on 3 to the power of 5 minus 4x, and this will be equal to 27 to the power of, and let's say 2x minus 3. So we'll have this equation, and we're thinking, oh, what does x need to be such that this left-hand side equals this right-hand side? And by using guess and check, it might take you a long time, or you might get some actually decimal answer which you can't do by hand. So you'd need to know your exponent laws and know how to solve from here. So what you want to try and recognize is I have two different bases currently. I have a third and I have 27, and I want to try to make them the same base. So the way that I'm going to do that is I'm going to realize that 3 has the potential to turn into both of these as our base if we just have some sort of power on them. So a third is the same as 3 to the negative 1. And I've used this law here. If I have 3 to the negative 1, that's the same as 1 on 3 to the 1. I've moved this up to be 3 now to a negative power. And I did that to the power of 5 minus 4x. And I'm going to rewrite 27 as 3 cubed to the power of 2x minus 3. Now from here, I have a power to a power. So if I have a power to a power, using this rule here, I multiply my powers. So 3 to the power of, and I multiply negative 1 by both of these terms. It'd be negative 5 plus 4x. And I will have then 3 to the power of, and I multiply the 3, it'll be 6x minus 9. And I've done this such that now I have 3 to the power of something equals 3 to the power of something. And hopefully we can use the recognition step there that 3 to the power of this is 3 to the power of that. Well, this must equal that. The powers must be equal to each other because I have the same base. So I can go straight to the line. Well, therefore, negative 5 plus 4x must equal 6x minus 9. Okay, now from here, I can just solve for x. I can move the 4 over as a negative, so it'll be 2x. I'll move the 9 over as a positive and add it to negative 5. And therefore, x is equal to 2. So I have solved for this value of x here in this equation. And I used some exponent laws in the process. Okay, so this is just an introduction video. Try some of the IB exam questions that involve solving functions that have exponents.